This is the mechanical rig I'm going to use for my SCADA project. It's the first update really to let you know what's going on. I'm using the MG996R 360 degrees servo because the 28BYJ is terrible when it comes to current. It's either energized or not, which is not ideal for what I want to do. I want to plot graphs with, you know, what kind of load is on and etc, etc. The second cool thing that got implemented is this lovely Hall sensor, and you've seen the LED when the magnet passes. Let's do it again. Magnet here, boom, and there's a magnet here, so I can measure the RPMs and maybe do some honing of the contraption when it starts, as in boots. Now, the torque at this low RPM is stupidly tiny. There's literally, I'm barely touching it with my fingers, and it's just not doing anything. So I'm going to increase the torque, so don't go anywhere. And apply. As you can tell, it's sped up, and now it's a bit louder. And now I need to apply significant amount of force to get it to, oh yes, that's quite a bit of force I have to apply here. So I will be adding more stuff. The other thing I want to actually implement, let's see if I can stop it or slow it down first. Actually, let's see if it stops. I've asked it to go to 90 degrees, which should be, yeah, full stop, really cool. So now I've used a different, as in spare, MG996R servo, and this is a number 180 degrees variant. So what I want to do is measure the temperature of the actual DC motor that's inside. So I'm thinking to either make this cut longer and glue a DS18B20 temperature sensor and get readings of that, so I can plot energy use versus RPM and temperature and do some interesting graphs and analysis. Well, yeah, anyway, that's for it at the moment, and hope you enjoyed that one. Cheers, thanks for watching.